So let's talk about JPA class inheritance. Right? As I mentioned earlier, there's a disconnect how Java represents data and how that can be represented in a relational database. Right? That there's some disconnect on certain features, certain things happening one way in the Java world, and there not being any analogous implementation in a relational database. Yes. So what these object and relational mapping tools, such as JPA, what they do is they do the best they can. They say, well, to do inheritance, this is what I can do. This is what I can offer you. Obviously, there's no one-to-one mapping. There's several ways of doing the same thing. You just need to tell me which way, and I have a default way of what I would like to be able to do. But if you don't like it, you can override me and tell me what you want me to do. Make sense? Right? So we'll look at the default behavior. There's three different strategies that JPA uses. There's the joined, also referred to sometimes as the normalized representation, and this is what most people would expect. When we said we were expecting a different tables for different classes, this is what we would have expected, right? And this is what a DBA or data analyst would expect, right? A normalized data model. If we want, JPA can do that. Right? This is but this is by far the slowest implementation, but it is it uses less space but more time. Okay, this one, the single table, is the default one. Right? The default implementation called the single table implementation, and it's called the denormalized implementation. Right, where it takes all the fields from all the different classes, right, and merges them into one single table. Right? And then it uses dtype to be able to know which type it is. Make sense? This one is the fastest, but it trades time for space. Right? It uses more space. Right? So that's very common in our industry, right? Where space is cheap, and we give more relevance to time. But there's a third one that is kind of like in the middle of the two, where it is normalized. It's denormalized in the. It's normalized in that you get one table per class, but you also get the performance from single table by copying all the fields from the parent tables. They're copied onto the lower tables, right? So that at the leaves of this hierarchy, of this inheritance hierarchy, right? The tables at the leaves have all the fields from the previous classes, right, in the hierarchy, in the inheritance hierarchy. So let's take a look at them. First, let's look at the joined, the normalized strategy. Is the one we would expect. Okay, so if you have something like this, where you have a question, and question has it's a base class that has maybe the name of the question, the number of the question, how many points. So it has all the fields that are common to all questions. And then you have different types of questions, specialized questions. You have true and false questions, fill in the blanks questions, and multiple choice questions. Yes? So we're going to look at this same data model, but implemented in those three different strategies. Okay? So let's look at the joined version. Right? So here's the class, and we're saying that this is a base class, the base question, and I've appended at the end. Which example are we looking at, right? So we have the base question, and this is the joined version. And in the joined version, we have all the fields that are common to all questions, right? You have a primary key, it has how many points this question is, the title of the question, the description of the question, any instructions for answering this question, yes? Okay, so all questions have that. And here, we're saying it's an entity. Also notice the add table. We never looked at that. But if you can specify the actual name of the table that you want to use, the actual SQL name of the table. Yes. By default, if you don't specify the name of the table, it derives the name of the table from the name of the class. Right. So the name of the table will be the same name as the class. And if it's camel case, it'll pull underscores and whatnot. Yes. But you can specify. You can say exactly the name of the table that you want. your table, the name, and whatnot. Everybody okay? So up to this point, there's no difference from what we've seen. The only thing that's new here is that it says at inheritance. Right? So it's a decorator saying, I want you to use this strategy. Don't use the default strategy. Use this strategy. Right? It says inheritance. Use the inheritance type dot joined. Joined. See that? So what that's going to do is going to say, okay, well, don't use the default strategy. Use the join strategy. What I mean is that I want 3 tables, 1 per class, right? And to reconstruct the instances, you're going to have to join all the tables, right? Foreign keys with primary keys and retrieve everything for me. It's the slowest by far, right? And it's not it's not usually the way we go. Here's each one of the classes, the true or false question joined. From Java's point of view, these classes are always the same, right? From Java's point of view, from Java's data model point of view, all these classes are always the same, right? The only difference is that we're annotating them differently, giving JPA a hint on how we want it to map to the relational world. That's the only difference. Okay? From Java's point of view, they're all identical. Entity, we're saying table name. We're saying that the name of the table is joined, true or false question, and the name is true or false question joined. Notice we are inheriting from base class, and we're saying that we have a field called is true. It's Boolean. Just like we can override the name of the table, we can also override the name of the field. Okay, the name of the field typically is taken from the name of the variable, the class variable. Yes, right. But we can override it by using the add column, and we can specify exactly what the name of the field we want. In this case, probably that's exactly what JPA would have chosen anyway, right? With an underscore in between. You can configure that something can be null or not, right? You can say no, this is not null, meaning it's a required field or not a required field. So yeah, that's the true/false question. Then we have the fill in the blanks, same thing. The string has the variables for a fill in the blanks that's not nullable, meaning this is required, right? If you try to insert a record without this variable, it will fail. It will throw an exception. It extends base question joined. So this is what it looks like, right? So this is what it generates the base question. We have a primary key. We have all the fields, description, instructions, points, title. Notice that we don't have the other fields from the derived classes. See that? They're not here, right? So it's different, right, than the default implementation. And we have the other classes, the true, false, and the fill in the blanks. They only have the fields that pertained to them. Okay, so here we have the ID and its true ID and variables. Okay, and they're both primary keys and primary keys, right? The repository, you would have a repository per class, so per table, right? So we have a repository for the base class, a repository for the true or false, a repository for fill in the blanks, and you can retrieve each individual type of object independently. So I can ask for all fill in the blanks. So I can ask for all the true and false. I can ask for the independent base. Right, for the service, I can. Here's an example on retrieving data from each one of them, right? Using the various repositories. For instance, here we're trying out. We're instantiating a base question. Setting the description, the instructions, the set points, title, and then we save it, right? And the ID, I don't know what the ID is. I think it's going to be ID 1. Here we're instantiating a fill in the blanks, right? 2, 3, 4, description, yada yada. Notice that we're setting the description, even though, because we're inheriting all those fields. The description we're inheriting, the instruction we're inheriting, the points we're inheriting. The only other field that is new to the fill in the blanks is the variables, right? That's the only other field that we have, and then we save it. For the true false, right? All these fields we're inheriting from the base question, and we only are setting up the is true to true or false, and then we save it. When we retrieve the base question, right? Notice that we have only the fields for the base question, right? The points, the title, the description, the instructions. We're not any one specific, right? We're not the true false. We're not the multiple choice, right? We're not filling the blanks. So we don't have any of those fields, right? We only have the fields that pertain to the base class. If we retrieve the fill in the blanks, is what we expect, right? It's the fields that are specific to us plus the fields that we're inheriting, right? But remember that the table is not storing any of this information. Yes, the table is not storing it. To retrieve this data, it had to join the two tables, right? The one from the base and the one from the fill in the blanks, right? And it joins them by the same ID, and then it retrieves data from both tables to give me back one single record, right? That's where the expense is, right? To get one record, to reconstruct this object, it had to query two tables and join them, right? If imagine that if you had several derived classes in the same inheritance tree, right? You would have to join, if you're asking for retrieving an object that is way down here in the inheritance tree, you would have to join all the fields from all the tables from all the classes in your parents, right? And that would be very, very expensive. You have to join 3, 4, 5, 6 tables, right? In as many classes as you have that are parents to you. That's why this particular implementation is not preferable, right? So notice that the data is spread out over 3 different tables, right? So some of the fields are in the base, some of the fields are in the true false, some of the fields are in the fill in the blanks, right? So if I ask for this question, right, this 3 would map to this 3 in the base question, right? And this 2, it would map to this 2 in this question, right? So if I'm asking for this true-false question, here's whether it's true or false. Plus, it would be joined with this record to retrieve the rest of the fields. And this one, this 2 would be mapped with a 2 over here, so that if I ask for this fill in the blanks, it would be joined with this record, right, to retrieve all the fields in the resulting record. Okay, right? Very, very expensive. The other one is the denormalized strategy. This is the default one. This is what we get for free. If we don't say anything, we don't specify anything, this is what we get. Right here, we're explicitly saying that we want the single table. Well, we don't really have to because this is what we get for free anyway. This is the default. The implementation of the class is identical. Nothing changes. Right? From Java's point of view, none of this is different. Right? They're all just a base class and 3 derived classes. Right? From Java's point of view, but from JPA's, we would have to specify which strategy we want. Same class, no changes, right? But the table that you get is what we did yesterday. We had yesterday. We have an additional field, a D-type field, right? Because what happened is that we copied all the fields from the other classes. Now they belong into one single table. So variables and isTrue are both from the 2 other classes, the 2 derived classes. And so, if this is a fill in the blanks, then isTrue will be null. If this is a true-false question, then variables will be blank, right? Right, for those records. And again, you're trading space for time for space. So the same repositories. And here's an example on querying each one independently. If you ask for base, if you ask for fill, right, or ask for true, right, you retrieve each one independently. And there's only one single table as opposed to 3 tables. Yes, right. There's one more. Right. There's one that kind of goes halfway between these 2, right. And the way you configure it is say that you want a table per class, right? Again, from Java's point of view, is identical, the same classes, that doesn't change. So the difference here is that, so the base stays the same. The base, you have ID, description, instruction. So that's the same, right? Notice there's no D type. There's no D type, right? But what you get is that in the true false, remember in the normalized version, you only had is true and ID. But here in the table per class, the true false is grabbing all the fields that you get in the base class, in the base table, and it's copying them over, right? Copying them over down to this table, right? So you're almost what we would expect, right? That we're inheriting all those fields again here, right? And same thing for the fill in the blanks, right? We have originally we only had ID and variables. Now we get all the fields from our parent one, right? From our parent table. Right, from Java's point of view, they all look identical. And if we're retrieving base, retrieving variables, and true, false. Okay, there's a couple of references if you want to read up on this some further. So this implementation, is as fast as the denormalized solution, right? Since if you have the base. If you have the base class here, it would generate a base table, right? And if you have the derived classes, it would generate a derived table, right? And the records, right? The records would contain all the values that you need. There's no need to join. There's no need to join because you have everything in that record, right? There's no need to fetch some of the fields in this table and some of the fields in this other table because I have the same fields that you have. So there's a lot of redundancy here, right? All the same fields that you had of the title and the name and whatnot, I replicate them here. So I'm wasting a lot of space. Yes? Right? But nevertheless, I am as fast as I would have been in a denormalized because I have all the values here. There's no need to go fetch data from anyone else. Okay, this is preferred from a DBA's point of view, from a data analyst point of view. They would prefer something like this, right? Since it's denormalized, they don't. But it's also preferred by developers since there's no you get both the best case time and space. Okay. All right. You're free to choose which one you want. I would go with the default one. I think it's the easier one, but I leave it up to you.